See Standard 12th Max Chapter 6 XI 6.6 Applications of Vector Algebra. So second form, equation of a plane perpendicular to a vector and passing through a given point. See, this is a plane given for you and is perpendicular to the vector n vector, and also it passes through the point A where P is an arbitrary point. So the position vector of a point A is vector A and position vector of a point P is vector R. So in that case, the equation of the plane is given as vector R minus vector A dot n vector is equal to 0, where n is a normal vector, A is the position vector of a given point, and R is the position vector of an arbitrary point. Now we'll do the sum. See the question number 3. Find the vector and Cartesian equation of the plane passing through a point with the position vector 2i plus 6j plus 3k and normal to a vector I plus 3j plus 5k. So we have to find the vector and Cartesian equation, two form of the equation of a plane, and the plane passes through the point here. They be given as vector A. Vector A as 2i plus 6j plus 3k vector. And normal to the vector, this is normal vector, vector n is 2i plus 6j, normal to the vector I plus 3j plus 5k vector. This is the normal vector. So the vector equation is given in the form vector R minus vector A dot n vector. See, we are going to apply this vector R minus A dot n vector. This is equal to 0. So just you can take the dot product, minus vector A dot n vector is equal to 0. Vector R dot n vector is equal to vector A dot n vector. So substitute vector R dot n vector as I plus 3j plus 5k. Vector A as 2i, here they given 2i plus 6j plus 3k dot n vector I plus 3j plus 5k. So just R dot vector I plus 3j plus 5k is equal to I with I is 1. So 1 2s are 2 plus j dot j is 1, 6 3s are 18 plus 3 5s are 15. So this is equal to 20 35. So left side vector R dot I plus 3j plus 5k. So this is the vector equation of the plane. Answer for the first question. Then next question, Cartesian form they ask you. Cartesian form of the equation. So in that case, Cartesian equation. I just replace arbitrary point vector R as xi plus yj plus zk dot I plus 3j plus 5k is equal to 35. Just take the dot product. So here 1 into x plus y into 3y plus here this is 5. So 5z is equal to 35. So this is the Cartesian equation of the plane passing through a point and normal to the vector. See the question number 4. A plane passes through the point minus 1, 1, 2 and the normal to the plane of magnitude 3 root 3 makes equal acute angles with the coordinate axis. Find the equation of the plane they given. See, actually the plane passes through the point. So the point we take it as vector A is equal to minus 1i plus 1j plus 2k. See, a normal to the plane whose magnitude, usually normal vector we represented as vector n. Magnitude is given, whose magnitude is 3 root 3. See, and also it makes equal angle. It makes equal angle with the coordinate axis. So it makes an angle alpha with the x-axis and beta with the y-axis and gamma with the z-axis. Makes equal angle with the coordinate axis. Makes equal angles with the coordinate axis. Coordinate axis. You take respectively. Okay. So that means the cosines, direction cosines are same. Cos alpha is equal to cos beta is equal to cos gamma. Cos gamma. So just I replace here. We know that the formula here, the square of this direction cosines are equal to 1. Cos squared alpha plus cos squared beta is equal plus cos squared gamma is equal to 1. See, cos alpha, all these are equal to 1 means I just replace all these as 3 cos squared alpha. Cos squared alpha is equal to 1. So, cos squared alpha is equal to 1 by 3. So, cos alpha is equal to 1 by root 3. Cos alpha is equal to 1 by root 3. That is, cos alpha is equal to cos beta is equal to cos gamma. This is equal to 1 by root 3. See, we have taken the concept here. It makes equal acute angle with the coordinate axis. Which one? The normal vector. So, what about the unit normal vector here for us? Unit normal vector n cap is equal to vector n. Let me write that also. Vector n divided by modulus vector n. So, what is vector n here? It is a vector I plus vector j plus vector k divided by modulus of vector n. Modulus of vector n is root of 1 square plus 1 square plus 1 square root 3. So, this is our unit vector. So, what is our given normal vector? Vector n is equal to, that is vector n cap is equal to vector n by modulus vector n. So, therefore, from this I get vector modulus vector n is equal to modulus vector n, you cross multiply n cap. This is a given normal vector. So, what is given in the modulus n vector? 3 root 3. 3 root 3. Write that n normal vector n cap vector I plus vector j plus vector k divided by root 3. So, root 3 cancels. So, 3 into I plus j plus vector k. So, this is a normal vector of the given plane. So, the plane passes through the point they given minus I plus j plus 2k. And normal to the vector is 3 into I plus j plus 2k. Therefore, the vector equation is vector r minus vector a dot n vector is equal to 0. So, we have to get the vector equation. This I can write it as vector r dot n equal to, take to the other side, vector a dot n vector. So, I replace just vector r dot n vector is 3 into Sorry, this our normal vector is 2. Normal vector is 3 into here. Just you can multiply here. 3i plus 3j plus 3k is equal to vector A is minus I plus j plus 2k dot 3i plus 3j plus 3k. Just keep this as it is. Vector R dot 3i plus 3j plus 3k. Take dot of this minus 3 plus 3 plus 6. So that is equal to 6. So from this I can take one 3 constant outside. So 3 R dot I plus j plus k. So vector R is dot I plus j plus k vector. 3 cancel, so you will get answer 2. So this is the vector equation of the plane passing through the point and normal to the vector. Answer for the first question. Next is Cartesian form. Cartesian form. So replace vector R as xi plus yj plus zk. I plus j plus k vector is equal to 2. Just I dot I is 1. X plus y plus z is equal to 2. This is the answer. Cartesian form of the equation. See, just you can go through this. So here the given important point is it passes through the point they given, and also the magnitude of the normal vector, and that normal vector makes equal angle. Using this we get the unit vector of this normal vector, and from that we get the vector n, because they given only the magnitude of the vector, and also the second concept they given equal angle it makes with the axis. So using these two we may get the normal vector. So you have to understand this and then come to the equation of the plane. This is vector equation of the plane and this is the Cartesian form. Thank you.